Hey there, Mr. Weaver here, and this is Topic 8, Lesson 2, Average Rate of Change, Part 2. After this lesson, you need to be able to calculate the average rate of change within a table based on the given interval. You need to be able to calculate the average rate of change for a function or equation or expression based on the given interval. And you need to be able to compare average rates of change over two different intervals. You'll know you're successful after this lesson if you can identify the start and end values within a table for the given interval, calculate the change in values for a table for the given interval, evaluate a function for an interval, calculate the change in values for a function, and compare the average rates of change. The first thing we're going to look at are tables. So we want to calculate the average rate of change for this table between 3, 7. So remember that bracket is interval notation. It tells us where to start and where to end. So here we're going to start at x equals 3 and end at x equals 7. For a table, you need to find those values in the table. So there's x equals 3, there's x equals 7. The values we're going to use are the f of x values. So from 3 to 7, it went from 4 to 36. That's where you're going to calculate the change. So from 4 to 36 went up 32. To get that, I just subtracted 36 minus 4 is 32. So I know that it went up 32 to go from 4 to 36. Then for the average rate of change, we're going to divide by how long the interval is. Here the interval was 4 units. So to get that, I subtracted 7 minus 3 is 4. So I'm going to divide 32 by 4 and find that the average rate of change for this table between 3 and 7 is 8. So it went up 32 over 4x units, giving us our rate of change of 8. Now it's your turn. Pause the video. Calculate the average rate of change for this table between 5 and 9. Let's check. You should have got your average rate of change was equal to 24. So we're starting at 5, ending at 9. Those two columns. It went from 12 to 108, which is an increase of 96. And it took 4 units to get there. The interval was 4. So 96 divided by 4 is 24. Let's look at another example. Calculate the average rate of change between -1 is less than or equal to x is less than or equal to 1. So I want to start at x equals -1 and end at x equals +1. Again, we're going to find those in the table and use the values that go with. So here it went from -1 to -250. For this one, I'm going to use Desmos for my subtraction. So I needed to go from -1 to -250. So I'm trying to figure out how much that changed. I'm going to go subtract backwards. So -250 minus -1 is -249. So it went down 249. So I'm going to put minus 249. And then how many units did it take to get there? Here our interval is 2. 1 minus -1 is 2. So our interval was 2. Our average rate of change then, -249 divided by 2 is -124.5. Now it's your turn. Pause the video and calculate the average rate of change between 4 and 6. Let's check. You should have found that the average rate of change is -9. To get that, start at 4, end at 6. So this time it went from 36 to 18, which is down 18. It took 2 units in the interval to get there, so negative 18 divided by 2 is negative 9. Next, let's find the average rate of change for an expression. So calculate the average rate of change between negative 1.5 and positive 0.5 for the function x squared plus 4x minus 5. So for this, we're going to start at x equals negative 1.5 and end at x equals 0.5. For expressions or equations or functions, you need to evaluate the function when x equals negative 1.5 and evaluate it when x equals 0.5. So evaluate it for your start and your end. What that means, if you remember back to topic 2 and 3, evaluating means that you plug in that value for x and calculate out what it is. So if I plug in negative 1.5 in for every place that x was, shown here in the parentheses, and I calculate that out, I end up with negative 8.75. I can do the same for x equals 0.5, plug it in everywhere there was an x, and I get negative 2.75. Evaluating these functions is a good place to use Desmos. So if we head over to Desmos, if we could type in our function, notice it does give you the graph, so you could type in your function and find the average rate of change by graphing. However, we want to know based on evaluating the function. So I'm going to use the calculator to evaluate. In here, I'm just going to change everywhere there was an x to the value that it wanted. So negative 1.5, and I'm putting it in parentheses just to show that it's in the same place. I get negative 8.75. If I copy it and do the same thing, but this time it was for positive 0.5, I end up with negative 2.75. Now, while I'm here, I might as well just calculate how much it changed. So I'm going to subtract where it ended minus where it started. So negative 2.75 is where it ended, minus negative 8.75 where it started. It went up 6. So from the start to the end, it went up 6. So using Desmos, we were able to figure those values out. How did it change? We also just calculated that out. Negative 8.75 to negative 2.75 means it went up 6. How long did it take to do that? What was our interval? Negative 1.5 to 0.5. That is 2 units. So it went up 2. Positive 6 divided by positive 2 is 3. So our average rate of change for this function over the interval we were given is 3. Now it's your turn. Pause the video, calculate the average rate of change between 2 and 7 for the function x squared minus 9x. Let's check. You should have found that the average rate of change here was 0. Let's see how we get that. If we plug in 2 into our function, so 2 to the second power minus 9 times 2, we get negative 14. If we plug in 7 for the function, 7 to the second power minus 9 times 7 is also negative 14. It went from negative 14 to negative 14. That's a change of 0. And just to continue the process, the interval here was 5. So 0 divided by 5 is 0. There was no change from the beginning to the end. Finally, let's look at comparing average rate of change. So for the function f of x equals 3x squared, which interval has the greatest rate of change? Is it between -2 and 1 or between -3 and 2? So for this, you're going to need to evaluate the function for both intervals. So the first one, we're starting at x equals -2 and ending at x equals 1. The second one, we're starting at x equals -3 and ending at x equals 2. So for the first interval, I'm going to plug in -2 into our function and 1 into our function. If I plug in -2, I get 12. If I plug in 1, I get 3. So how did that change? It went down 9, and it took 3 units to get there. Our interval was 3, so the average rate of change here is -3. Now let's check the other. If we plug in -3 and calculate it out, and 2 and calculate it out, we end up with 27 and 12. So this time, it went from 27 to 12, which is down 15, but the interval was 5. So it's 5 units between -3 and 2. Dividing this out, I also get -3. In this case, they are the same. Both rates of change are -3 for these two intervals. Now it's your turn one last time. Pause the video. See if you can figure out which has the greatest average rate of change for the two intervals for the function -2x plus 2. Let's check. You should have found that they are the same. They both have an average rate of change of -2. The first interval started at x equals -1 and ended at x equals 2. The second interval started at -2 and ended at x equals 1. So if we plug in those values into our function, when x is -1, we get 4. When x is 2, we get -2. That decreased by 6, so -6, and the interval length was 3. -6 divided by 3 is -2. If we plug in the other interval, -2 and +1, we get 6 and 0. Again, it is decreasing by 6 over an interval length of 3. Again, -6 divided by 3 is -2. So both of those had the same rate of change. In this lesson, we learned about finding the average rate of change from a table and from expressions. So in a table, it involves using the interval to find where the start and end values are located. They should already be there. Then just determine how much the f of x or y value changes, and then divide that by the length of the interval. That will give you your average rate of change. For functions or equations, the average rate of change requires a little bit more work because you need to evaluate the function first. So evaluate the function for your start value in your interval and for your end value. Once you've figured those two things out, then you're going to figure out how much it changed, divide by the length of the interval, the same process as it was for the table. If you need to compare the average rates of change for intervals for the same function, you're going to have to figure out the average rate of change for each interval. Now, in the examples that we saw, both times the average rates of change ended up being the same. That's not always going to happen. So when you're figuring it out, if you come across a situation where you have different average rates of change, you need to think about which one is actually changing more for every unit. So, for example, -2 is a greater change than +1, since going down 2 each time changes the function more than going up 1 each time. If you want to graph it, think of it in terms of the slope. Steeper slopes are going to change faster. They're going to have a greater rate of change than flatter slopes. So if you think back to some of the examples that we did, even though it was negative 124.5 was a much greater change than when we had positive 3. So after this lesson, do you now know how to use the start and end values for the given interval to calculate the average rate of change of a table? Do you know how to evaluate a function for values in the interval and determine the average rate of change from those values? And do you know how to compare the average rates of change within a function over 2 different intervals and determine which one's greater or less? If you're not sure about these things, go back and look at some of the different examples and how we calculated the average rate of change for each type to deepen your understanding of the concept. And that's the end of lesson 2 on average rate of change, part 2.